Hey folks, how's everyone going today? We are looking at something a little bit different again. It is the Dragon Q6A that Radxa were kind enough to send us, and it's got a Qualcomm SoC in it. So I'm pretty excited to have a look as it's a little bit new to me. And of course, Radxa makes some very good products. So without further ado, let's rip the plastic off and get into this thing. Well, this is unexpected but pretty awesome. Inside this rather beautiful little plastic case, they have some really cool stickers, which I thoroughly like. I'm not sure what that Chinese, come on autofocus, there we go. Not sure what that Chinese wording says, but I'm sure it's something great. And I really do like the little I love Radxa thing in the bottom left, and just these circular stickers that you can see there. So these are definitely going to get plastered around somewhere, but nice little bit of swag thrown in there. And besides the plastic case, the more important thing is that we've got this beautiful manufactured PCB here. This board is pretty densely packed, and it's got a few things that are different to what we've looked at before. Namely the Qualcomm SoC, of course, and I'll get into the details about that in a tick, but it's also got a 2230 M.2 slot there, and it's got two external antenna headers there. The rest of it kind of fits their standard Type A form factor as far as the layout, but it does support UFS, not just eMMC, and I'll touch on that a little bit more later as well. So going around, we should probably start with the SoC. So this SoC is the Qualcomm QCS6490. This has 8 cores all up. The first one is a Kryo Gold Prime core at 2.7 gigahertz. Then it's got 3 Kryo Gold cores at 2.4 gigahertz, and then it's got 4 Kryo Silver cores at 1.9 gigahertz. So it's got like ultra high power, and low power. It's then got the Hexagon 770 NPU, which is 12 tops, which is pretty bloody awesome for an SBC. And it's got the Adreno 643, I think it is, GPU at 812 megahertz. Other than that, up here we've got LPDDR5 at 5.5 gigabit, you could say. It's got our standard GPIO header that you used to down here. It does support, it has onboard SPI flash, but it does have both the eMMC and UEFI support as we talked about. And then you've got the SD card slot on the back and the eMMC slot on top. Now that is PCIe, what was it? It was Gen 3 2-lane and 2230 form factor. So you've got a lot of throughput on this if you want it. The HDMI output that we've got over here supports HDMI 2.0 and will do 4K at 30 FPS. You then have a variety of interfaces for cameras and displays. So you've got 2 dual lane MIPI CSI connectors here, so you can have 2 roughly 1080p cameras attached there. You've then got a quad lane MIPI DSI, and I'm sorry if I'm pointing at the wrong one. I'm pretty certain this is the MIPI DSI. And you've got quad lane MIPI CSI here as well. So you can use 4K or 1080p cameras, up to 4 of them theoretically as well with this. And from what I understand, it supports 4K 30 FPS encoding and 4K 60 FPS decoding. So there's a fair bit of power there. The Wi-Fi module built in is the AIC 880 D80 chipset. So that's Wi-Fi 6 with Bluetooth 5.4, also supporting BLE. And we've of course got those external antenna connectors there. So I'm assuming this is going to be dual channel, but we'll see. We've got gigabit Ethernet over here with your standard PoE header connector there, which you've seen on many other products. On the USB front, we do have a USB 3.1 Type A on the go port there, which is nice and out of focus. And we've got 3 USB 2.0 ports, and then we've got a USB 2.0 Type C port, which is primarily the power port there. We've got a 3.5mm audio jack for your headphones there. We do have, where is it? I saw it on here before, there we go. An RTC battery connector, which is becoming more and more common, thankfully. That can be really important. And it's 12 volts in via DC or the input header. 12 volts in via PD or, of course, the input header. Now, their specs say that it will chew about 18 watts on light load or 24 watts on full load, which is worth knowing about. Now, this Qualcomm SoC is ARM V8. So technically inside it's got 4 cores that are ARM A78, so they're the Kryo Golds, and it's got 4 cores that are ARM A55, so those are the Kryo Silvers. It does support Windows on ARM, which we'll touch on in a little bit. And UFS, as I mentioned, so this connector with two B2B connectors there for what is typically an eMMC module, supports UFS, which is has 4K sector support and is also full duplex, so it's a lot faster all round. They did send me an eMMC module, not a UFS module. I don't have any to test here, but we're not going to be benchmarking the disk speeds. We know this is probably going to absolutely fly because they rarely screw up when it comes to that sort of performance. We'll do a generic benchmark on it. We'll look at how you can install Windows on this thing if you want to run Windows on ARM. We'll have a look at the OSs that are available and some of the other neat little features that I was surprised to see work on this thing. So let's get it all plugged in and have a crack at it. 1 second. All right, now before we plug this in, I've got it all set up with my Finersi FMB58 here so we can see what it's drawing. HDMI is all good to go so we can have a watch of it too. There is one more small minor housekeeping matter that gets away from me sometimes, and that's PCBWay, because they're continuing to sponsor this channel. I'll keep it short and sharp. I'll try to stick a QR code on the screen, but for all of you followers that watch my videos, you get $5 off your first order if you use the QR code that should be on the screen somewhere now, or the link below in the description. So if you're just doing basic PCB prototyping, that means you just pay for shipping, which is fantastic. That cost me about $8 if I was to use that. They, of course, also do heaps of other stuff like 3D printing, CNC machining. They've got all sorts of tools that you can buy from them as well. And if you, I'm curious about that. I haven't seen it before. And if you haven't seen, they also have a PCB design contest if you're into that. So I'd recommend checking them out. Thank you to PCBWay for sponsoring this channel because they're paying me to make these videos for you. Of course, thank you to Radxa for sending me this too. But do click that link below and support PCBWay because they support us. It means a huge amount to me. They are actually good people with good products that I use personally, not just for this YouTube shindig. Now, moving on to this, I've got it all set up as I said, and I just want to have a look at what happens first when we plug it in. So if we cut to this little view, I'm going to plug the power in here and we'll get, all right, so we straight away have a little green LED. Let's shuffle this down a bit. All right, so it's triggered the 12 volt, which matches what the documentation says. Now, these are the 12 volt inputs, sorry. Earlier, I was pointing at the PoE input, so that's not the 12 volt. What we also seem to have here is a very zoomed, very low resolution UEFI BIOS output, which is very, very interesting. So I'm assuming the card underneath it has no image because we did stick that card on there. What we're going to do now then is jump over into the documentation and have a look at how to flash this, because I think that's going to be quite important. So let me pull that up and we'll go across there. I'll pre-download the tools and we'll flash the latest image onto this together. The tools that we're using work on Mac, Linux and Windows, I believe, so it should make it nice and easy for everyone following along. All right, so we're on the documentation page now, and you see it's a little bit different because this is still ARM, but it's not Rockchip. So it's using different tools and different methods. In short, put your storage in, put it into EDL mode, and you need to use, it says use a type A to type A danger noodle, which I'm not a fan of. So we're going to try a workaround with a type A to type C. Set up the EDL tool environment, which is basically just extracting it, installing the drivers, and then adding the system path. So we'll go through that in a second, and then flash it to USB. So you need to copy the extracted image that you download into the SPI boot firmware folder. So to do that, if we go to the downloads page, we want to grab the 512 byte sector version for us because, or the 512K sector version for us, because that is what you want for eMMC like we're using. If you have UFS though, you want to use the 4K sector version. Then of course, there's a few little notes about exactly which SPI firmware version to use, and you just download that down here and their tool along with the device driver. Now, once you've got those, you'll want to extract them all. So if we have a look here, I've got the SPI image, which has quite a few folders. I've also got the extracted firmware here, which is from GitHub. So I'm going to straight away stick that in here, like they say to do. We then have our tool set. So is this a zip with a zip? I just extracted that zip. It's got another zip inside it. All right, so let's just extract the zip that was in the zip and get rid of that. We're on Windows x64, and so this advanced system properties, then in here, environment variables, and in our user variables, I don't know why I dragged it over there. We just add a new one as far as path goes, which includes that. So then we'll go, okay, okay, okay. And if you already have a terminal open, you want to close it and open another one. Otherwise it won't have that updated path in it. And then lastly, we have here our drivers. Now, by default, I don't use manufacturer's driver installation tools. You never know what it's going to do. So what we can do, if we pull up our device manager here, then back over on the board itself, we have our boot button, which is a bit hard for me to see actually. Let's unplug that. Oh, it's up here. I was missing it then. So we will hold that plugged in, slightly awkward position, pushed in and plug it back in, and then we'll let go. So we've only got one LED on now. And if we have a look at the, yep, nothing on there either. So this should be in the EDL mode now. And what we want to do is plug this in. So instead of using a type A to type A danger noodle, so come on, rotate, I'm going to use type A to type C. So the documentation says to plug it into, where are we, UFS. So if we come back over here, entering EDL mode, all right, so it's that one that we need to use. It shows it clearly there. So we'll jump back to where we were here. We are going to let you see what I'm doing. Plug this in under here. I've got my wireless keyboard and mouse plugged into that top one. And then because I'm using type A to type C, I'm then going to plug this into a type C port on my computer and hope that it works. Let's see what this has done. There we go. We have this QUSB bulk device. So I'm going to do update driver, browse my computer, and I'm just going to grab this path and paste it in here. And there you go. It's signed and everything. That is what I want to see. So that's most of the steps. The last thing will be the actual flashing in theory. So one trick I learned is over here, you can just type CMD and it's going to open up a terminal for you at that location that you're in. One of my mates showed me that at work the other day, which was really handy. Then in theory, we can pretty much paste this. The only thing we change is path to loader and the storage type. So if we go EDLNG loader, is that, I assume that's the loader file that they've given us. Let's go and have a look. Because the instructions are a little bit vague. They expect you to know a bit of what's going on. Yeah, all right, there's some ELF files there. So memory SDCC, what does that even mean? Yeah, I assume that's going to be eMMC, and the image name that we have is almost the same, but it's R2. So let's grab that example and over in the command prompt, just move this over and minimize that. Can we, yeah, we can even make that font a bit bigger for you. It might be easier to see. So this is EDLNG loader using that ELF file as the loader there, specifying SDCC, which I'm assuming is going to be the eMMC starting at on slot 0, starting at sector 0, using the image that we downloaded, which is, oh, I thought that would autocomplete. We'll just copy that file name, paste it there, and we'll hope this works. Let's see what happens. Whoa, not happy. File does not exist, prog fire hose ddr.elf, but it does. And file does not exist, that output. All right, give me a tick. I'm going to have a quick read here. Won't be a moment. All right, a quick bit of twiddling around showing me that you actually need to add the full path to the images. So now, there we go. It found the interface, it found all the images, it's pushed the loader across, and now it's flashing the module that we've got at a nice 40 megabits per second. So that's not bad at all. That should be done shortly. And then I'm not sure if this is going to auto reboot or not, but what it might be worth doing is I'll get the view ready to go. In fact, let's go back to that view because that makes it nice and easy. So if it does auto reboot, we'll probably see the little blue LED come on. Now, of course, this does support Windows as well. It also supports Qualcomm Linux, which Qualcomm make for these SoCs, supports Deepin, Fedora, Armbian, and Arch. But as I said, it also supports Windows, and they do have different instructions for that I will show you on the documentation. We won't go through it ourselves today, but it's quite straightforward. This is probably the most complicated part of it that we're doing now, and this wasn't even that hard. Whilst it's flashing, to reiterate, what we did is we downloaded the installation tool, the drivers, the loader, and the image itself. We've then extracted it all. We put the image in the loader folder. We extracted the installation tool, which is a zip in a zip, just because Turtle's all the way down. And then we added that to our system path. We extracted the driver and installed that once the device popped up in Device Manager. And then we launched Command Prompt from this window and started flashing it using the full path names. You could also skip adding this tool to your system path if you didn't want to, or your user path, and also reference it by the full path name. I mean, I should have just done that anyway, but I didn't know that we're going to have to reference a file that is in the same folder that we're currently in by the full path. So this is nearly done now. Let's give it a hot minute. And then what we're going to look at is power consumption, which right now is pretty low. We're getting, where are we? 1.6 watts, so 150 milliamps is not much at all. And we'll see how much it chews once it's booted up. We'll have a look at the driver options, the performance settings. There's information on how to use the NPU that I'll show you, along with the Windows on ARM instructions. And then we'll test out WebGL, do a system update, and benchmark it. So, oh, there we go. Let's quickly get rid of these things and see, is it booting up? No, I've still only got a blue light up there. So we'll test those out. And the benchmark I'm very, very curious about. Now, I guess the next thing to do is to power cycle it. So unplug and plug back in, and then rotate this again. There we go. So there we go. We've got our blue light there as well, which you should just be able to see. And it's immediately drawing a fair bit more. It's drawing 3 watts, 2 and a bit watts, 3 and a bit watts. And we have some system output. Wow, I cannot see that. Hang on, what's going on? So it's outputting 4K, or this Elgato is giving me 4K, but the actual system display, there we go, was very small at 640 by 480. Here we have a bit more. We have a nice blue text, which I've not seen before, from some of the early kernel patches or changes there that are occurring around all the systemd startup things. GNOME Display Manager seemed to stop then, or not to start, which was a little bit odd. It might have timed out, but it might be using LightDM, or it might have duplicate packages installed. This is the latest image though. It is listed as stable. They do list information on their website about, on the GitHub page about what works and what doesn't as well, though I didn't even bother looking at that, to be honest. When you first use these things, you log in with Radxa and Radxa. That's RADXA for the username and password. And of course, let's quickly get rid of that, but let's see if we can make this a little bit easier. Resolution. Whoop, no, not that one. Why did you do that? Displays. Make it a bit easier to see, because 4K as a default is pretty insane. Let's go 4K, but with a 300% scale. There you go. Anyone watching at home that is on a 1080p display should be able to see this now as well. So that seemed to work really well out of the box. One of the first things, of course, is going to be Wi-Fi. So let's see if it, yep, great signal strength of all of my Wi-Fi networks, both the 2.4 gigahertz and the 5 gigahertz one. So we'll join my Pi-Fi with my nice complex password there. And when you get any system, you typically want to do your updates first. Now, one thing that comes up from time to time that I want to point out is with Radxa devices, you don't want to do apt update and apt upgrade. The reason is that they kind of handle that, they kind of handle that for you. And I'll show you what I mean. If we go into a super user prompt, we want to run rsetup. Now, this is the Radxa setup, and it handles kind of, everything that you actually want to do something with. For that, the system update in here is going to handle everything. That's weird. All right, it might be doing some updates in the background. What was that saying? I didn't even read it. It's locked, held by package, read lock file, may break it, update has failed. All right. It's because, yeah, it is doing its own updates in the background, so we'll give that a second to keep going. Doing apt update and apt upgrade might install some things that aren't compatible because, of course, this system is, you know, built on the SoC from Qualcomm and is heavily customized, whereas your image, especially this one, might be pulling unknown updates from unknown repositories. You know, it's all well and good to pull all the updates, but the rsetup tool handles the required firmwares and compatible firmwares and everything like that specifically for this board that you're on, which it even says is the Dragon Q6A, which I think I forgot to say at the start. So that's always the safe way to do it. And I am just curious, there we go, that looks like it's finished. So if we go back to rsetup and we do the system update, it's going to handle it for us now. It's going to install the latest updates and it's going to do it safely with the least chance of breaking your display output, your Wi-Fi, or any of the more sensitive parts on an SBC such as this. Now, speaking of other things you might want to do with it, whilst that update's going, if we jump back and have a look at the desktop here, there's a few other things really worth looking at, in my opinion. So one of the things that we're going to be doing is this performance setting. So setting all the scaling governors, viewing the available frequencies, and then setting the maximum frequencies for each of those sets of cores. You can then also set the GPU frequency. Another thing worth knowing about is that you can install the Vulkan compatible drivers, which is a MESA turnip driver. So that gets Vulkan working, and you can even test it on the Dragon Q6A, which I think is pretty awesome that they've got that. One thing I was excited to see is this WebGL user guide, but mostly the WebGL user guide says just to install Chrome and it should work. And I'm definitely testing that out, which is really awesome. But what a lot of people might want to know about is, you got all your instructions here for the different hardware interfaces, how to use the NPU. And it's actually really quite easy. I had a bit of a read through some of these and everything is pretty straightforward. It's much the same as any other model conversion process that you might use, and most of the same models are all compatible. They have ready to go demos though. So you can get Llama 3.2, which is a 1 billion parameter large language model, and pretty much follow these instructions. You can even do it with the 4K version, so you've got a bit more smarts in there. And use it locally. You can of course install a interface on top of this if you want. It does explain to you though the prompt construction method, which can look a little bit messy, but it's how these LLMs are trained to ingest and output data. And you can essentially say that, you know, there is text you're putting input here. So you've got the system and the user prompt, which is you're a helpful assistant. And then the user prompt is give a brief introduction to relativity. And then you've got the output here with new lines injected and whatnot. If you've done anything techie before, you've done much with LLMs, this will make make complete sense to you. But if you read this thoroughly and follow along, it should just work for you. And 110 tokens a second for a 4K context length is pretty good in my opinion. Tune this as you see fit, use whatever model you see fit. These are just the ones that they've already ported across for you. So if you go and have a look at Modelscape, I don't know if this is going to be in English, but there should be some more models you can browse through there and pick what works for you. Look, little English button down there. There we go. Some of it's English at least. So the documentation is really comprehensive, including setting up VS Code, installing Casa OS. They've got their own model zoo. That's what we want to see. That is actually really cool. And their use guides are specific to this machine, which not all vendors do. So let's have a flick back and see how this is going. That's nearly done. I'm very excited about that. Whilst that's going, what we're probably going to do is in here, we'll just open up another terminal and we'll have a look at the IP address it's got. So 1042.2019. That means back on my computer over here, if I enable that display for you, I'm just going to go to, actually that'll do, SSH Radxa at 10.42.20.19 and doesn't have SSH installed. That's all right. That's really, really easily fixed. Go back to, where are we here? And as soon as this is done, 91%. We'll just wait for this. We'll get the next command lined up. We're going to do sudo apt install -y open SSH server. That'll give us open SSH. Then we can connect from the computer and not have to deal with two different displays. It'll make it a little bit easier. So I'll do that, and once that's done, and be back in a moment. For what it's worth, it's drawing just under 3 watts whilst it's doing these updates, which I think is pretty reasonable. But when it's benchmarking, I'll also note what it's chewing, and I'll add that to the description below if you're curious. All right, so that's all done. And it turns out that SSH server was already installed. It just must not be started. So I installed Chromium browser, which I was really disappointed to see was using Snap. And that's something I really, really dislike about Ubuntu is the Snap packaging system. It's just so bloated and slow, but that's my own opinion. You leave yours in the comment below if you want, and like and subscribe whilst you're down there. It's actually pretty bloody handy. So what we're going to do is systemctl enable SSH. Not going to start it at this point because we do have to reboot first, since we just installed kernel updates and driver updates and firmware updates and all of those things. So we'll also just give it a quick init 6 and reboot. And after that, we should be pretty much good to go with connecting over SSH, and then we can set the performance options and actually see how well it goes. So yep, that's all booting back up. Everything looks happy. Yes, and Radxa. There we go. So straight away, I'm going to jump into a super user terminal because we're going to have to make some pretty radical system changes here. We do need to do these. So I've got to copy and paste these one at a time because we don't want to get all the prefix bits in the commands there. This is probably going to be the easiest way to do it. Now, before I'm setting this, it's currently consuming about 2.5 watts in case you were curious. And so far, all of these are going well. There we go. We don't care about the available frequencies though. We only care about the maximum frequencies. So, I need to be one folder back. So let's set all of these maximum frequencies and see if it starts drawing more than 2.5 watt whilst idle. No, it's still about 2.5 watt. That's good. Change to the GPU and we'll also do the same thing. So we'll set a user space governor and then we'll echo the frequency that we want there, which is the maximum frequency. Now, for a minute, we are actually going to go back over here. So we'll log in with our same account as before because we want to see that WebGL working that we're talking about. That's got me quite curious. Of course, we don't want to do that in Firefox. I'm very annoyed that it comes with Firefox as well because it's a huge package to update. I guess Chrome being Snap makes it a big package too. So if we go about GPU, all right, so we do have WebGL. That's what we want to see. There's no Vulkan because we haven't installed the Vulkan drivers. Let's quickly do that as well, just out of curiosity. If we come back here, Vulkan user drivers or Vulkan user guide, and just do that install. See what happens. We might just need to restart GDM so that our display has the latest drivers and everything like that. So we'll double check what it's running. It is GDM. We'll do system CTL restart GDM, and then we'll go back to this desktop. So now if we log in again, I believe that doing it that way should give us those updated drivers. I may be wrong, but I think I'm right. No, still says Vulkan disabled. I'm not sure exactly why that is, if I'm being completely honest. If we have a look at the terminal and go Vulkan info, it all does look happy. It might just be a Chrome thing. So we don't need it to be working. Vulkan, it's using OpenGL, which is perfectly good enough. And this just means the desktop can use Vulkan if you're going to be playing any games on it. But OpenGL and WebGL are more than enough. I mean that, they're perfectly fine. This is going to work absolutely flawlessly. What doesn't work is my typing ability, obviously, tinkers. And you can see here, there's no lag. There's no issue whatsoever with using this. It feels like a desktop computer, and this is running at 4K. So if we look at the most recent Zimmerboard video, give ourselves a fresh advert. Why not? It feels and looks and is acting like a desktop. So WebGL benchmark, this should fly along as well. And I must say, so far, I'm really, really happy with how this is performing. Yeah, I don't care at this point. So we'll hit start on that. Whilst this starts to run, another thing that might be worth mentioning, or at least bringing up, is that I do have a Patreon. So if you want to support me off YouTube, which makes a huge difference, it is a growing community, starts at $3 US a month, and you get to watch the videos without any ads. You get, behind the scene access, support from me, you get your name shouted out, and a bunch of other things. So you can go and see the membership options and choose what suits you, and of course that benefits me, and it is hugely appreciated. But even just a like and a subscribe below does make a difference. Every little bit helps. I don't do this to make the money. I don't make any money that I put in my own pocket from this yet. It just supports me having fun and doing this. So thank you, regardless of what sort of support you show. And as we can see here, this BaseMark test is flying along and not having any problem whatsoever, besides my resolution, with working as an SBC should, assuming everything was going to work, which they don't always do, as you know. So getting back to the desktop computer then, what we want to have a look at is how we can make this work for us to benchmark it. And really, I'm not going to do too much in our setup. I'm probably just going to make it boot to the command line. That's the most important thing to me. And for the sake of benchmarking now, since we've updated it, I'm just going to do system CTL GDM stop. Well, got that backwards, didn't I? Stop GDM. And from here, I can download and benchmark this system. That covers pretty much everything that I wanted to show you. If you were curious about more, all the instructions are in here, including other OSs, such as getting Windows set up. I always encourage you to read the instructions thoroughly, especially for these things, because it can be a lot harder for you if you don't. But, that's just my preference. You may have another one. I will put the benchmark results below, as always. I will include the power rating, as always. The last thing that we need to do then is consider where this is going to fit on the SBC tier list. So that's this thing. And I haven't really added to one of these in a couple of weeks now, but we've got a few little factors to look at. And I don't have my cheat sheet in front of me, so I do apologize. I will be kind of, flying off the cuff here, most likely. But performance and reliability, 5 out of 5. Price, it starts at $99, and availability, it's available from at least 3 different places online. So I'm going to give that 5 out of 5. That's a 2 gig model, but that's still more than enough to benchmark. So 5 out of 5 on price, especially given the DRAM costs going up. Accessories are actually really good. So coming back over here, they support a whole pile of accessories, including an armored case with a heatsink that a lot of their other things support. It also then, of course, has a standard M.2 interface, even though it's 2230 and a little bit short. The PoE headers in the standard position, standard GPIO headers, so all of that is fantastic. The web browser works out of the box. It booted first go. The drivers were signed, so the accessories and everything were fantastic. They've got really good documentation, a lot of examples, a few different image variants on their GitHub, and they support multiple other OSs. I can't even remember what all the scoring systems are that I have to give this, but I'm going to give this an S tier because there isn't really anything that I could actually fault. There was no problem or concern. Like, it's even got dual band Wi-Fi 6, it's got UEFI, it supports UFS, it's got gigabit networking instead of 10100, it's got 4K and 1080p camera support, it supports HDMI with 4K, or you can use a MIPI DSI connection. It's even got a legacy, I must say, 3.5 mil barrel jack for headphones. This is a solid all-around unit that Radxa have nailed as far as performance. Like 12 tops NPU is amazing. Price, reliability, documentation, images available, compatibility with third-party systems, low power consumption, ease of use, working out of the box, sexy stickers and case that come with it. Everything else, I don't know what to say. If you've got something that didn't work for you, or if you had a different experience, I would love to know, because this is one of the easiest, the fastest, the cheapest, and the nicest SBCs I've used today. So thank you to Tom and his team, including Kathy, Peter, and the rest of them for sending this to me and letting me try it out. That is hugely appreciated because I don't have money to constantly splash at these things as much as I wish I did. Also, thank you to PCBWay again for sponsoring this channel. For the times I do have to buy a product from a lot of other vendors because they don't all send it to me to try out for free, PCBWay cover that, and that's a massive, massive help. And of course, thank you to all of you, because you viewers that are liking, subscribing, and all of the things below keep contributing positively to this channel, and it's pretty much the only reason I do it. It's fun, and all of you make it fun for me. So I hope you have a fantastic weekend ahead, and I'll catch you probably next weekend as I try to catch up on the backlog of interesting SBCs and tools and gadgets that I've got. See you then.